On the bench this morning, I've got a Pioneer SPEC-2 stereo power amplifier from the early 70s that I have been working on for the last couple of weeks. I've got it standing in this position simply because I had to do some unique little work on the current mirror transistors that you see there and there. Now, the original super matched Mitsubishi transistors that went in there became leaky and mismatched, and they were not good anymore. And since they are notoriously difficult to get, and the ones that you get is probably new old stock or so, I prefer to have gone the method that X-Ray Tony suggested on YouTube. I think I must maybe include a link to his channel in this video, where he, you get a PNP transistor that's similar spec to the original super matched pair that went in there. And if I can just find the package, I'll be able to tell you what transistors those are, but it doesn't matter for now. The only trick here is to do, the final trick is to do the thermal coupling. And I've done mine with a copper sash that I just gently soldered shut, or just bonded with a blob of solder on the one side. And then I just capped it with a bit of epoxy on top, so that I know that it's secure, it won't fall off. And the copper serves for good thermal bonding. And yes, that's the thing that I'm busy with this for now. Apart from the one channel that was blown, partly due to I don't know, a mishap somewhere in the past, and a blotchy repair as well, I've done a complete restore on this channel. All defective solid-state devices have been replaced with new equivalent devices, including the output transistors. And then both channels, the meter board, the power supply board, and the main power supply received new electrolytic capacitors. These big boys were quite a bit of a challenge as well, because it's getting increasingly more difficult to find capacitors that fits the same physical dimensions as the originals that came out of, for instance, an amplifier like this, because you can get the same value, same voltage capacitors these days, but they like a third of the size of the originals. So these ones are from Alcon, a manufacturer called Alcon Electronics, if I'm not mistaken, and they have the same diameter as the original caps. Now I'm going to do something like this and move over here and just get the package with the original caps, the original Nippon Chemicons that were in the Pioneer. Massive capacitors. There's all four of them. The value 15,000 microfarads at 100 volts. So yes, nice and beefy, but not as beefy as the caps in the Krell KSA 100 I'm still busy with, but I'm going to make a video of this amplifier as well. I did start with some recapping on the bias control boards, just doing that nice and neat to spec. And the next step with this Pioneer today is doing its symmetrical clipping and power, well, if you want to call it like power soak test, to just ensure that it complies to the specs laid down in the service manual. And then I'm going to do a sweep harmonic total harmonic distortion sweep and a frequency bandwidth sweep on the audio precision analyzer. And then this bad boy can go back to its very happy owner down in Cape Town. This is just a shot from the top side. There you can see the big power supply caps. And there's the audio channels. Done a lot of work on the audio channels. I've negated the wire wrap system on the wires going to the power transistors, simply because they were just too tarnished. I've incorporated or replaced the original potentiometers with multi-turn potentiometers that enables for much easier and better bias adjustment, and the blue potentiometers on either side is for the symmetrical clipping current limiting circuit. And then we come to these little SVTs, the thermal tracking diode string devices. I've had a particularly difficult time with this channel's devices. Apart from the legs that were broken off against the package, after a lot of stress and head scratching, I discovered that this one's polarity is flipped inside the package when it was made. All of these have the anode indicators on the right hand side, but this one's is on the left hand side, and I never noticed that until recently. So that's a thing to look out for if you're ever working on a SPEC-2 and you can't figure out why the channel doesn't want to bias. Because I ended up following a thread on Audio Karma where there was a Belgian guy that had endless troubles with his SPEC-2, the one channel that didn't want to bias up. It stayed cold. The same happened to this one. Ice cold. It was playing music, relatively clear, and yeah, just couldn't figure out why I didn't want to bias up. Because no matter, even if I've taken out the bias pot, no luck. If I've taken out the SVTs, no luck. But I must also just add, please, just bear with me, is that I have replaced some of the in-audio circuit diodes as well, and driver transistors, and getting up to this point. So it might be a combination of the polarity on this device being flipped and a faulty semiconductor somewhere on the board. But that was a challenge. That was certainly a challenge. And other than that, I gave it a play last night, listened to a full John Mayer album on it. It sounds marvelous, it sounds good, and it's extremely close to going back to its owner. Thank you, thanks for watching.